Thank you for the introduction, Janet. I'm going to share my screen here and just launch right into it. Okay, so can everyone see this presentation and see my screen?
We can see it, yep.
Okay, all right, great. All right, well, Janet covered the introduction already for the most part, but yeah, I just wanted to acknowledge BACOG for putting on this whole project and for really taking initiative to collect all this groundwater and surface water data, and also the USGS for contributing to taking some of these measurements. My co-authors are Alan Jones and Connor Healy, and we'll get to the components that they did for this project. And the motivation for this study really was to update the previous BACOG report that was developed by Kurt Thompson at KOT Environmental Consulting in 2015. And so that report essentially established the methods that BACOG was going to use to monitor groundwater and surface water conditions in the area. And so that report essentially measured a lot of the lake levels in the area, measured groundwater levels, and developed the first potentiometric surface for the BACOG area in 2014. And that essentially set up the methods that we are employing for these subsequent years and are going to cover in this report. And so the purpose of this study was to update that from 2015 and to evaluate the changes that have occurred since he wrote that report to now. And we also wanted to add in the component of looking at trends in municipal water use through time. That's something that Kurt Thompson may not have had access to, but we at the Water Survey have all those records, so we wanted to add that in here. And in general, we just wanted to provide additional insight into the hydrogeology of the BACOG region to support you guys in decision making and just trying to understand the groundwater and surface water systems in this area. I first wanted to talk about the geology of the BACOG region and really to understand what's going on in the subsurface and also with some of the creeks in the area, really to know what the geology of the area consists of. So underlying your feet in the BACOG area is all this glacial material. And so this is a mix of sands and gravels, clays, silts of various different sizes, and it varies greatly in how well it's sorted and how well it's not. And but in the BACOG area, and here, just for a reference, this solid black line here, can everyone see this pointer? The solid black line there is the BACOG boundary. And so I sort of divide this area up into an eastern half and a western half that I'll be talking about for the rest of the presentation. In the western half of the BACOG region, there's a lot of sand and gravels at land surface. So if you're walking on the ground and you're at a stream cut, you could actually see these sands and gravels. They're immediately at land surface. And this is a formation that we refer to as the Henry Formation. And this really is the primary aquifer in the BACOG region, or the primary shallow aquifer. And I'm getting a lot of feedback from somebody. Do other people hear that?
I don't. I'm going to mute myself.
Okay. Yeah, that's a lot better. Okay. So the western half is really where the sandy material is at land surface. And you can see here, right at Spring Creek, Spring Creek is actually in direct connection with that aquifer. It's running right over it. And also the Fox River here, which is, this main river right here towards the west. That's also in direct connection with the aquifer and the sand and gravel material. This aquifer, it dips down towards the east and becomes buried. And so this is what all this light green stuff here is. It's called the Wadsworth Formation. And that's a formation that's really rich in clays and lots of silts. So it doesn't hold as much water as the sand and gravel material. And that's an area where what we consider is confined. And so the sand and gravel aquifer is essentially covered up by these sand or these silts and these clays that limit the amount of recharge that's entering the aquifer. And so try to keep this in mind as we go through the presentation, where you kind of have this this difference here between the eastern half of BACOG and the western half of BACOG. And so here in this red line right here is a cross section that I'm about to show you. And so this cross section crosses Spring Creek right here and Flint Creek right here. So let's take a look at what this looks like. So this is a cross section. It's basically just taking a slice down, and we're just seeing what's underneath at that particular transect. And so again, this orange material is the sand and gravel formation that we refer to as the Henry. This is the primary aquifer, primary shallow aquifer in the region. And you can see that it's at land surface here, and Spring Creek is running right over it. And as you move towards the east, it starts dipping downwards and becomes lower in elevation. And it's all covered by this thick Wadsworth Formation, which is, again, the really clay-rich and really silt-rich material, and which prevents recharge down into the aquifer. So here we consider the aquifer to be unconfined. Here we consider it to be confined because it's covered by this stuff. And then underlying all the glacial material is the shallow bedrock units, and it's mostly what we refer to as the Silurian dolomite. So this is a limestone. It's pretty much a limestone, but just has a bit more magnesium in it. And where it's fractured, it can be a pretty productive aquifer. And there's portions in the BACOG region where it's actually eroded slightly, and underlying that is the Maquoketa Shale that's exposed. Okay, I wanted to talk about water use in the BACOG region now. And within the BACOG area itself, it's pretty unique in a sense that it's entirely groundwater dependent, but a lot of the water supply is mostly from private wells. This is sort of a unique case in comparison to most of Illinois, where most people get their water from central water systems. But here in BACOG, it's mostly from private wells. And Janet and Tomas in the GIS department did an analysis of how many private wells were in the area, and they estimated that it was around 70% of BACOG residents actually use private wells. So Barrington and Tower Lake are essentially the only two towns in BACOG that have central water systems. And then outside of the BACOG region, it becomes much more diverse in terms of water use. Here in Elgin, they use the Fox River water. And in Crystal Lake and Lake in the Hills, they're on groundwater, but they have a mix of shallow wells, shallow bedrock wells, and then also deep sandstone wells. And then as you get towards the eastern area over here, those communities are all on Lake Michigan water. So it's quite a diverse use of water in the greater region.
I'm sorry, but I'm going to unmute myself. Paula McCombie, South Barrington. We have a municipal water supply as well that services about, I don't know how many restaurants, as well as shopping center, as well as 392 residents. So you may want to add that, our deep well municipal system. And we do have one. So,
Oh, okay. All
okay.
right.
All right. Sorry.
Yeah. Okay. Thank you. We have in our records that, yeah, that we don't have you guys marked down as a central water system. Okay.
Okay. Thanks.
That's in South Barrington.
Yes, South Barrington.
And how many wells do you guys have?
We have 2 deep wells for that shopping area. That area.
Hmm.
It's a PUD, and there's 392 on the build out. I think there's 20 homes left yet to be built in there, and then a shopping center with, I don't know, 13 restaurants right now, I guess, are open.
Okay.
And I'm wondering if maybe, I mean, we have that information too. I'm wondering if maybe it didn't get pulled for the study because they are deep wells, and that wasn't really what the study was about. So maybe that's why.
Yeah. So that was my next question. Was are there like deep sandstone or deep bedrock wells?
Deep, there are a couple. They're deep. Deep wells. I'm not sure which one they are. They're I'd have to go back and check the records. I can't remember offhand.
Okay. I see.
But anyway, when you just say municipal systems only in Barrington and Tower Lakes, it doesn't differentiate the fact that those are shallow municipal wells in your program. So
Sure.
anyway, okay.
All right. Well, thank you for bringing that to my attention. Yeah. That. Okay.
Thanks.
Okay. Are there any more questions in terms of water use within the BACOG or outside of BACOG region?
Jan, it's Karen. Just want to question Lake Barrington. What do we call their municipal supply to the industrial area? I don't know where that's from, but we shouldn't miss them if we're going to add the South Barrington piece. Or
Well, Dan and I talked about that.
Yeah.
Because originally he had it as a municipal supply community, but none of the residential areas supplied by a municipal system. There's a community system in Lake Barrington Shores, but it is the industrial park. So, I mean, primarily the community is, you know, however you want, we can add that information in if that's what you're asking.
like a footnote.
My intent was to kind of, in general, just show where most residents get their water from, not necessarily, you know, if it was either a particular subdivision well or an actual well used, you know, for industry of some kind. Really, it was to emphasize just where do the majority of residents in each town get their water from.
Great. Understood.
Okay. All right. I'm going to move on here. So I wanted to talk about the actual monitoring program in this region. And so there's lots of different data sets that we can take and try to make a story out of what's happening here in terms of surface water and groundwater conditions. So the USGS operates several stream gauges. There's 3 on the Fox River. There's actually 2 right here. They're just very close together. There's 1 in South Elgin, and then they also have 1 on Poplar Creek. In addition to the USGS stream gauges, the Flint Creek Watershed Partnership also operates 4 stream gauges on Flint Creek. These are these yellow triangles here. The difference between those is that the USGS measures both stage and discharge. So it measures the height of the water and also the volume of water, whereas the Flint Creek stream gauges just, for the most part, measure stage elevation and not volume of water flowing. So that's the surface water component. In terms of groundwater monitoring, there's a series of dedicated monitoring wells within the BACOG boundary and outside of it. And most of those wells were drilled by the Illinois State Geological Survey, and that's all these pale blue dots here. So all those pale blue dots. And some of those wells were taken over by the U.S. Geological Survey, and there's been continuous monitoring at those sites. So those are very valuable data sets, really allows us to see the seasonal changes at these wells. And at the ISGS wells in the pale blue color, those are just measured periodically. And then in addition to the dedicated monitoring wells, there's also been a mass measurement every July since 2014 to measure water levels at municipal sand and gravel wells and shallow bedrock wells. And during this July mass measurement, all of the dedicated monitoring wells are also measured, and that's been measured by either ISGS staff, Illinois State Water Survey staff, Kurt Thompson, or BACOG staff. So it's been a collaborative effort to get all those. And at the municipal wells, those are all measured by the water operators for each of those towns. Okay, so we wanted to take all of that data and put that together, and also make a story about what's happening in terms of municipal water use. And for the municipal water use story, we looked at data that has been given to us through the Illinois Water Inventory Program, and we looked at data from 2005 up to 2018. And the reason we cut it off at 2018 is because the program is several years behind in terms of data collection, and it usually takes a year for us to gather all these records, and then some time after that to actually review and QA/QC it. And so we cut it off at 2018, and from 2015 to 2018, there's been very minimal sort of review of that data. We've corrected for outliers, but we haven't had the chance to vet all the data from 2015 to 2018. But from 2005 to 2015 is we have very solid records for, and we've QA/QC'd it to the point that we think that's correct. We're not going to touch it anymore. And then we could divide those withdrawals up between the shallow bedrock system and the sand and gravel system. And so for all the communities that participate in the mass measurement, and for all the communities that are within BACOG, the BACOG boundary, those are the communities that we pull together to analyze this municipal water use data. And then in terms of taking all of the stream gauge data and the monitoring well data at all those dedicated monitoring wells, we use those to create what we call potentiometric surfaces. So these are maps that represent groundwater elevation of the sand and gravel aquifer. We did not make one of these for the shallow bedrock system because we just didn't have enough data to do that and to have enough confidence in doing that. So really the maps I'm going to show you in subsequent slides are just for the sand and gravel aquifer, which we also refer to as the Henry Formation. And then we could take those maps of groundwater elevation and subtract them, and we could see how those change from year to year. So we could take one surface and subtract it from another to get that change. And we use the July mass measurement data to do this. So the maps that I'm about to show and that you've probably seen in the report just represent July conditions. And then where there's surface water that we thought that was in direct connection to the aquifer, we use the elevation of those stream segments for use in our countering. So for example, this plot to the right shows the hydrograph at the USGS Lake Barrington monitoring well. So in blue is what's happening in the aquifer. And then in black is the Flint Creek stream gauge that's very, very close to it. I mean, they're within 50 feet from one another, or no, maybe more than that, probably a couple hundred feet from each other, but they're very close. And as you can see, when there's increases in the stage of Flint Creek, you could also see somewhat of a corresponding increase at the monitoring well. So really what this is telling us is the surface water and the groundwater systems are very connected here. And so what's happening in terms of elevation is going to be pretty close to what's happening for elevation in the groundwater system. So we also took the USGS hydrographs and just plotted those against precipitation data from NOAA. There's a nearby climate station that's just outside the BACOG region. And we also did an analysis of Baseflow using a USGS method. And so Baseflow is the component of surface water discharge that's directly from aquifers discharging into that stream. So basically under low flow conditions, when there hasn't been a big rainfall event, the water that you see in a stream is primarily from groundwater, and that's what we refer to as base flow. And we did that analysis on Fox River and Poplar Creek, and we used a seasonal Mann-Kendall test to determine if there's a positive or negative trend in base flow. So basically just to determine, is base flow increasing or is it decreasing?
Dan, could I ask a question? So you said when you were talking about the graph on the slide, you said something about a couple hundred feet. Now this graph is showing how closely related Flint Creek water levels, the elevation of the water level is to the groundwater water level, right? Which is only between 740 and 749.
Right.
So I mean, but overall, that is showing how closely they're related and how the groundwater is probably feeding the creek. But what was the several hundred or the couple hundred?
Oh, so spatially on the ground, you know, the USGS monitoring well is not too far away from Flint Creek itself.
Oh, I see.
Yeah, so sorry if that was confusing.
Thank you.
No, basically what I'm trying to say is the elevations, the elevations that we see in terms of the monitoring well are very close to the surface water elevation at Flint Creek in this particular area. Okay, so I first want to just go through some of the plots that we came up with for municipal water use. And so the main plot here is combining all the towns within and outside of BACOG. And you guys could refer to the report for the complete list of the communities that we included here. And the few big things to note in this plot is the shallow gray bars, or the light gray bars here are sand and gravel withdrawals through time. And then the black bars are shallow bedrock withdrawals through time. And so from 2005 to 2018, there's generally been a slight decline in sand and gravel withdrawals when looking at the total withdrawals from all these communities. And the shallow bedrock withdrawals have essentially remained pretty flat. And in most years, around 75% of withdrawals are from the sand and gravel aquifer system. And in the last 5 years, so from 2014 to 2018, 2019 roughly, there hasn't really been much change in the sand and gravel aquifer system. You could argue maybe it's going slightly down, but in general there hasn't been too much change. Oh, sorry, go back. And then to the right here are just plots for Barrington and Tower Lake, which is what we had as the primary just community water supplies within BACOG. And you'll notice the magnitude of withdrawals are, you know, far less than the total, obviously. But in general, it looks like Barrington water use is going down slightly through time. And there really isn't too much trend in terms of withdrawals from the shallow bedrock system. And you could maybe make the argument that sand and gravel withdrawals are slightly declining through time. And at Tower Lakes, most of their water use is just from the shallow bedrock system, and that's declined slightly over time. And there really isn't much use from the sand and gravel system at Tower Lakes. Okay, so now I wanted to go through the maps of groundwater elevation. And so these can be somewhat confusing. Really what these represent is the elevation at which the water will be in a well if you were to drill at that particular location. So theoretically, if you were to drill a well right here, you would expect that elevation of water in that well to be at 750 feet above mean sea level. And so because we have sort of a mixed unconfined and confined area, this is sort of a hybrid between what typically is referred to as just a water table elevation and what's referred to as a potentiometric surface. So these maps essentially combine those two. And so you could basically read these like a topographic map. So there's peaks and there's valleys and low spots. And so the blue shaded colors are the high elevation and the darker browns are the lower elevations. And these can be used to show where groundwater is being recharged and where it's discharging. And you could also use these to discern where this groundwater is flowing and along certain flow paths. And so in blue here are essentially the groundwater elevation highs. And so these are areas that are pretty important sources of recharge. Either the aquifer is at land surface or it's getting readily recharged by something. And here to the west of the Fox River in Crystal Lake and Lake in the Hills, the sand and gravel aquifer is at land surface. And it's actually mined quite a bit. There's lots of sand and gravel quarries out there. And here in western BACOG, this is an area where the Spring Creek watershed runs right over it. So there's lots of lakes and wetlands and also Spring Creek itself. And every year, as we march through these slides, you're going to see that the elevations of the groundwater are just really high here every year. And so these are two important areas of recharge. And then in red is basically the area of discharge. So all groundwater in the region, or not all, but a lot of the groundwater in the region is eventually flowing to the Fox River. And also to note that as you get towards the eastern half of BACOG, the water levels start to decline in elevation, and that's roughly correspondent to where the aquifer is confined. So then we could also draw flow paths over these maps. And so basically your flow path of groundwater is going to be perpendicular to your contours. So again, just to point out here that you're flowing from high to low. And so right here, groundwater is discharging to the Fox River eventually. If here it's flowing towards Barrington, and over here also flowing to the Fox River, going away from this potentiometric high here at Lake in the Hills and Crystal Lake. Okay, so the thing that I wanted to note as we march through these slides, so I'll take all that off, is that the contours in BACOG don't really change too much year to year. They're going to change slightly, but not too much. So I'm just going to march from 2014 to 2015, and then from 2015 to 2016. And so here we still have a contour of 770 and 750 in this area, and it's not really going to change as we go. But this is changing a lot out here from year to year, and that's because this is where all the municipal use is, and that varies a lot from year to year. So here we are in 2018, and then finally 2019. Okay, so does anyone have any questions so far in terms of what these maps represent, or in terms of the differences so far between the 2014, 2015, 2016, and so forth surfaces?
If no one else steps in at this point, at some point, I'd like to ask you to address how much, how the water level is changing to the west of the Fox River. And even though the water is discharging to the Fox in that direction, the flow line is toward the Fox, that the aquifer system as a whole isn't necessarily limited to the Fox. So that area to the west of the Fox, as more water is being used out there, is that having some effect, or what is the effect? I know it's having some effect on water levels in our area, but how much effect and how does that work?
Sure.
And you can save that for later if you like, but
no, those are all great questions. Yeah, so towards the west here, the water levels vary a lot because that's where Crystal Lake and Lake in the Hills have a lot of municipal wells that tap that aquifer, and their withdrawal rates vary a lot from year to year, and so that's why that surface changes quite a bit through time. There's also some years where some measurements were missed, so the surface may pop up in that year or go down. But overall, it changes more out to the west than it does within the BACOG region because there's just more demands out there. In terms of how withdrawals in this area affect the BACOG region, the answer is that it's going to have very little. It's going to have very little effect on it, and the reason is because of this Fox River groundwater divide here, and this aquifer can be depleted in a sense, but it probably wouldn't affect BACOG region too much, considering that the Fox River is basically like this divide here. It would have to take a substantial amount of drawdown in here to really affect what's happening in BACOG. And at least over this 5-year time span, it hasn't, water levels out here have not really changed drastically to an extent that we think, whoa, this is a serious issue.
well,
Hey, Dan,
go ahead.
Oh, no, I'm going to change topics, Dan, so go ahead first.
Okay, so, but going back to the Kane County study in 2009, the water levels in Kane County and the southern part of McHenry County were, as I understood that report, its conclusions at the time, those were going to affect water levels in the BACOG area. Now, I know that the projections are not the same now in terms of what water levels will be going out a couple of decades. But there was, as I understood it, there was a relationship between the aquifers and what the water levels are to the west of us and how water is being used to the west of us, and that there would be an effect on water levels on the east side of the Fox, including Barrington Hills, Lake Barrington, and South Barrington, Barrington. So those 3 or 4 communities that were closest to the Fox showed some impact in that study, that there would be an impact, a decrease in water levels here because of the water withdrawals to the west and the changing water levels to the west. So is that not, is that not a valid conclusion at this point? Because conditions have changed and precipitation has changed and water pumping has changed?
I definitely have to review the Kane County report to definitively say, but I think it would take a really substantial decline in McHenry County and in Kane County to really affect what's happening in BACOG. Not to say that really substantial withdrawals couldn't affect what's happening in BACOG, but I think it would take a lot to get there. And I just wanted to make the statement in terms of, just from 2014 to 2019, what we have the data for, there hasn't been substantial changes in west of the Fox River for me to be concerned about water levels in the BACOG region. Does that make sense? Was there another question out there?
Yeah, this is Karen with the Village of Lake Barrington. Kind of going back to what you previously said about what counts for municipal wells and things. I noticed on this map, there's a Lake Barrington 1 and 2, which are 2 municipal wells that we have, basically one well that services the business park, and they're both in black. It says municipal well SG. So what does that mean?
Oh, that says F. Wait, you mean LB?
Yeah, it says LB1 and LB2. So I think that's referencing our, we have a municipal well for the business park, which earlier you said it doesn't count as a municipal well because it serves a business park in one of the earlier slides.
Well, no, not that it doesn't count as a municipal well, but just that I was classifying Lake Barrington overall as just a community that's mostly on private wells.
All right, so what does this mean here where it says on the side, the monitoring, it says municipal well SG in parentheses? What does that mean?
Oh, that it's a sand and gravel well.
Oh, okay. And the fact that it's black dot or a brown dot means that it's got a low elevation, like the water it's pulling from is a shallow aquifer, or that it's, I took this when you were explaining before that the blue dots meant there were kind of basically lots of water and the brown dots meant there wasn't as much water.
Oh, no, okay, so let me clarify this. All the dots that you see on the map, regardless of color, are sand and gravel wells. So they all tap the sand and gravel aquifer. Really what I was referring to as the brown versus the blue shading was just in terms of the potentiometric surface. So in blue is the higher elevations in the aquifer, in brown is the lower elevations of the aquifer. But every dot that you see on the map, those are points, those are representative of sand and gravel wells. Does that make sense?
Yeah, I guess I'm a little slow.
No, it's okay.
So I'm still not understanding when you say high elevation versus low elevation. You mean the high elevation of water underground? It's closer to the surface?
Yep.
Okay.
So if it's a high water elevation, it means that it's going to be closer to land surface. And if it's a low water elevation, it's going to be deeper and further away from land surface.
Okay. So the blue dots basically are getting from water from shallower sources versus the brown dots. The brown dots have to go deeper to get their water.
No. No. The color of the dots is only to signify who essentially owns the well, whether it's the ISGS, whether it's a USGS well, or whether it's a municipal well.
Okay.
So the colors of the dots don't mean anything in terms of elevation.
Well, on the side it says blue high equals high elevation, brown equals low elevation. What does that mean?
Sorry, the blue shading.
Oh, okay. I was looking at blue dots and I thought my screen
I'm
color was.
sorry. I should have, yeah.
Okay, so you're meaning
Okay.
like the color of the background there.
Yes,
Okay,
yes.
Gotcha.
Yes, the blue.
Okay. Never
yeah,
mind.
So like all this is, yeah, the blue shaded area versus, you know, the brown shaded area.
Okay, nothing to do with the dots. Got it.
Nothing to do with, sorry, I'll fix that when perhaps this presentation will be shared with all of you and I'll put in blue shading here.
Okay. Thank you.
Yeah. Okay. All right. So then we could take these maps of water elevation and see how they've changed through time by just simply subtracting them from one another. And so we did this for 2014 to 2016. And then we did this again for 2017 to 2019. And the reason that we split this up between those two time frames is because the protocol for measuring these water levels changed from 2016 to 2017. So in 2014, 2015, and 2016, all the municipal wells, so all the black dots, were measured under pumping conditions. So that means that the wells were on at the time when those water level measurements were taken. And then this sort of makes it challenging to do a year-to-year comparison every year, because if a well was on for, you know, an hour versus a day, you're going to have a very different water level. So we made the recommendation to Janet starting in 2017 to change that protocol. And so now from 2017 onward, those municipal wells have been measured under non-pumping conditions. So all the wells are turned off prior to taking a measurement, and that's really to ensure consistency going forward. And so we know definitively, okay, the wells are all off, these are a static water level. We can make a comparison and have confidence about some sort of trend through time. And so from 2014 to 2016, we have a general increase. Oh, so sorry, I'll clarify here. The blue shading, not the blue dots, and the sort of the orange and reddish shading is indicative of either an increase or a decrease. So blues are increasing, reds are decreasing. And all the area in gray is essentially areas of no change. So if it was plus or minus about 2.5 feet, we're saying it's essentially not, that's really not much of a change. And in the eastern BACOG area, in general, water levels increased from 2014 to 2016. And in the Crystal Lake and Lake in the Hills area, they decreased. But keep in mind here that all these levels were measured under pumping conditions. And so we could have had a situation where, you know, one year, a lot of the water levels were lower just because they were using more at the time that they took the measurement. So we caution in making really strong definitive conclusions. And, you know, we don't want you to see this and be extremely alarmed that there was a 10-foot decline at Lake in the Hills, because it could just be a reflection of variable pumping rates at the time that they were taken in July. But
is there a period of time that these need to be off for when you do the measurement? When you say that you do them in non-pumping conditions, is there a period of time that they need to be non-pumping for?
Yeah, that's a good question. Janet can clarify this, but I think it's at least a half an hour that the wells are off, and then preferably at least an hour or so that they're off. Is that right, Janet?
Yeah, actually, I used the 1 hour time. So
okay.
when we made this change, I had originally said to turn just indefinitely turn the well off for the pump off for half a day to a day. And then the next year is like, they're not going to do that necessarily. And we want to get everyone with the pumps off. So then I use the at least an hour. And so far, the indications on the data that they send to us when they take the ratings is that that's what they've done, at least an hour.
Yeah, and most recovery is gonna happen within that first hour. You're gonna get a substantial amount of recovery, if not full recovery, within well within that hour.
Great, thank you very much.
Yep. Okay, and so does anyone have any questions in terms of this map, in terms of change from the 2014 to 2016 period? All right, okay. So now we could do the same thing again, but this time we're going from 2017 to 2019. And so this is when all the wells were measured under non-pumping conditions. And there's a pretty large increase in Lake in the Hills area. We had, at some wells, there was over 40 feet of head change, so head increase. But there is also some declines here, like at East Dundee and at Algonquin. And so this is perhaps indicative of more water use at the time. Even though the wells were off, they could have been using the aquifer enough that regionally the aquifers were, the levels were depressed at the time that they were measured. But then again, in this eastern BACOG area, you have continued increase in water levels through time, and really not too much change in the sort of western half of BACOG, except for this drawdown here that happened at East Dundee. Okay, so now we could do an overall difference from 2014 to 2019. And I do just want to note, though, that the really large increases that we see out here, those increases would not be as substantial if the wells were always measured under non-pumping conditions. But this map is representative of both the recovery that you would see when the wells were turned off and an overall trend over time, measuring from static water levels from 2017. I know that's confusing, but that's why, I try to put this caveat in here to state that. But within the BACOG region, there's, except for the Barrington withdrawals and a little bit of withdrawals from Lake Barrington, there's really not much municipal water use happening. And so the increase that we see within this eastern BACOG area, we see that a lot in the monitoring wells. And this is, I think, very telling that your static water levels through time during July are increasing, and it's not as a result of because Lake Barrington happened to turn their wells off at the time or something. I mean, this really is representative of the overall aquifer trend through time. Okay. So now I wanted to just show you what's happening at the individual USGS wells. These are really valuable sources of data for us in terms of understanding how the aquifer works. And there's currently 3 wells that are monitored continuously. So this data is collected. Is it every 15 minutes or is it every hour? I'm pretty sure it's every 15 minutes. And there's 4 dots on the map because one of the locations moved through time. So there used to be one at Deer Park, and then that was moved to South Barrington. So let's just go through them one by one. The first one here is the Lake Barrington monitoring well. And this is in an area where the aquifer is very close, if not at land surface. And so we call that unconfined, and it responds quite rapidly to rainfall. And so when there's some pretty big rainfall events, you also see an increase in the aquifer level occurring pretty much simultaneously. And from roughly 2014 to now, there's been about a 5-foot increase if you kind of compare these low points, or if you compare some of these high points. It's hard to state a definitive, increase over that time span, just because, it depends on where you pick your points out. But in general, you can see that the lows are tending to increase over time. And we also see this at North Barrington. There's also roughly the same increase in water level through time. You'll notice though that it's not as, it's less jaggedy, and that's basically because it's not responding as readily to rainfall events. And so this is more of a confined aquifer response. And at South Barrington, this is more of a confined aquifer response. So it's covered more by glacial material. There's less direct recharge to it, and but there's some kind of influence of a pumping well here. We're not quite sure what it is, but you can see that during the summer months, it really drops down and then tends to recover each summer. And but in general too, this shows about a 3-foot increase through time. And just to note that this period of record is slightly different than these two up here, because this started recording in 2017, whereas we're showing these from 2014. And then at the Deer Park well, that was installed from 2014 up to 2017. And that also shows an increase by a few feet. And you'll notice that when there's really big rainfall events, this aquifer isn't really, it's not responding rapidly here, but in general, you see these seasonal responses where water levels in the aquifer increase throughout the winter and the spring months, and then throughout the summer and fall months, it declines, and then you see, again, increase in the spring months. Okay. We also did an analysis on the Baseflow using the USGS stream gauge data. I wanted to point out though that there's several limitations to using the method that we employed. And the reason we use the method was just, it's a very standard method to use for Baseflow analysis. However, it's really meant for, it's meant to be used for stream gauges that are very low in the watershed and representative of the entire watershed. The Fox River stream gauges that we used, though, are not at the bottom of the watershed. I mean, the Fox River still flows all the way through Kane County and has to meet the Illinois River. And so we're kind of far up in the Fox River. And the Fox River also is quite modified. There's lots of dams on it, and a lot of the base flow is from wastewater effluent from communities further north and also in Wisconsin. So the results that we got from the Fox River were fairly unrealistic, and that's because of those two limitations. But the results that we got at Poplar Creek are actually quite good and very realistic. The reason that worked is because that stream gauge is located, at the low end of the watershed, and it's not a heavily modified system either. And just these trend lines here are, this is that seasonal man Kendall test that we did. And so in all three cases, the base flow does show a positive trend. I should just note here that this trend is not, it's to represent a qualitative increase or decrease, not necessarily like a magnitude of how much it increase or decrease in terms of discharge itself. But in general, really what to pay attention to is the base flow at Poplar Creek, because we had very good results for it, and the results of the man Kendall slope is positive. So it's telling us that the base flow is increasing through time. Okay, so water levels increased from 2014 to 2019 in the sand and gravel aquifer. And we know that because of several data sources. So we can see that at the USGS monitoring wells itself. So at North Barrington and at Lake Barrington, there's essentially a 1 foot per year increase over the study period. But we also see that in the ISGS wells that are monitored periodically. So this is just a table comparing the July 2014 measurements to the July 2019 measurements. And on average, there's a 5.58 foot increase, and they all increased through time. I noticed that I did catch a mistake in the BACOG report. So this is a correct number, 5.58. In the report, I have 5.8 feet. So I'll have to modify that and redistribute that to you guys. So the conclusion doesn't really change at all. Just it's just that there's one number missing in there. And then the other increases that we see are at municipal wells themselves. So I'm not going to show you all the data for that because there's a lot of wells that were measured during the mass measurements. But from 2014 to 2016, on average, the water levels increased by 2.2 feet. And then from 2017 to 2019, they increased by additional 3.2 feet. So both the USGS continuously monitored wells, the wells that we measure periodically at the ISGS wells, and the municipal water level, or the municipal wells, all generally are telling us the same thing. And that's that water levels increased over this 5-year time span.
Could I ask a question in here?
Sure.
When you said earlier that the first 2 years, 14, 15, 16, 3 years of data, 2 or 3 years of data, the pumps were on, so the water levels were lower. And then we changed it so that they were off, so they're static and across the board. They should be the same forevermore. Yep. Does the 5.6 foot increase include the increase from the pumping level to the static level, so that actually the overall increase could be less than this, or how did you figure that in?
Well, yeah, and that's why I divided it between these two time frames, so that you know, you generally know under these conditions where all the municipal wells are measured under pumping levels, you still see on average an increase from 2014 to 2016. And then when all the wells were measured under non-pumping conditions, on average water levels increased by 3.2 feet. But then if you subtract, or if you compare the overall difference from 2014 to 2019, it's a much larger number. It's 17.9 feet. And that's this is much larger because it's including the recovery that you would see at those municipal wells when they were turned off, and the general increase in the aquifer levels through time.
So I would caution the takeaway for the audience here that the 17.9 is not based on equal conditions, that
Correct.
the 5.5 or 5.6 is the far more accurate description of the increase in the water levels.
Correct. Correct. Yep.
Okay.
Yep.
Well, we've been lucky to get a lot of rainfall, that's what it amounts to.
Yep. Okay, so
Dan, excuse me, we're right at an hour right now. So
oh, we are. Oh, wow.
Yep.
Okay.
So probably want to. I'm totally fascinated with stay on and watch for forever, but some people may need to leave, so maybe we should get
Sure.
through the conclusions. Thank you.
Yeah, there's very few slides left. Okay, so the water elevation maps generally reflect the increasing water levels that we see at these wells. The potentiometric surfaces can help us define where there's areas of recharge and where there's areas of discharge, and how groundwater is flowing in the area. And we also see that there's increasing base flow at Poplar Creek. And so why are the aquifer levels going up? We think it's probably a combination of the fact that there was no significant droughts during the study period. There's been less municipal water use through time. So we went from 16 million gallons per day down to around 13 million gallons per day out of the sand gravel aquifer system. And this could be just a reflection of better household water efficiency, although we don't really have any data to support that. But just given that there was no significant droughts, maybe there was just less lawn watering in general. But water use from individual private wells is unknown for us. So what does this all mean? We think that in terms of water supply and quantity, you guys are in great shape. It's more than sufficient, and we would feel more concerned about water quality than about water quantity in this region. And the reason that we'd be more concerned about quality is because a lot of the aquifer is unconfined in BACOG, and it's directly connected to surface water systems. And so if there's chloride from road salt or fertilizers and pesticides just from people's lawns, that all ends up in the surface water and ends up in the creeks and rivers, and that can end up in the aquifer itself. So moving forward in terms of future studies, I think that should be an emphasis to try to understand if there are increasing chloride levels within the sand and gravel aquifer system. And the long-term monitoring that you guys have been doing at the USGS really is a great tool and really gives a lot of insight into seasonal water level changes, but then also long-term water level trends through time. And in terms of climate models and just predictions about sort of rainfall patterns, in Northern Illinois in general, storm intensity is projected to increase. Flood and drought events are predicted to become more extreme and more common. So we may have just more seasons where we see really, really dry periods and then really, really wet periods. And this is all going to change kind of the timing of aquifer recharge. So I think long-term monitoring at those USGS wells is going to be very vital for you guys in terms of understanding how the aquifer changes through time. And I'll save the acknowledgements. People have to go, but if you have any questions, I'll take them now. I think we hit all the acknowledgements up front. I'll just say thank you for all the water operators for participating, and all the other people listed here for making it all possible. Yeah, thanks.
Okay, so So now we will take questions from the board members, and maybe first and then others on the phone following.
Janet, it's Karen. I just need to say thank you very much, Dan, and I have to jump off this call, but excellent information and so happy that we have this report and all this great work. Thanks.
Great, thank you.
Yeah, Janet, I guess I'll say thank you too. It was a very interesting report, and thank you very much for the presentation. Thanks.
Thank you.
Janet, this is Karen with the Village of Lake Barrington. Are you going to be sending out Dan's PowerPoint?
Well, actually, Jen has been recording the whole presentation. So yes, the intent is to send it out to all of you and ask all of you to send it to your entire boards and plan commissions and so on, so everyone has a chance to see it.
Yeah, great. Thank you very much. I appreciate it. Very well thought out.
You know, I'd like to make a point that Dan and I have talked about over time as he's been, you know, looking at the data and writing the report. And also other people at the State Water Survey in particular who I've talked to over time, that groundwater water level monitoring, not the water quality, but the water levels, that kind of monitoring is a very long-term project. We just had our very first 5-year analysis from the baseline to through 2019 data. And I've been advised over and over that is a short-term analysis, and that trends in water levels in groundwater occur over a much longer period of time. So 5 years is not much of a trend. 10 years will be a little bit more. 15 years will be a trend. 20 years will be a trend. And while the conclusion right now is that 5.6 feet, I think 5.6 feet of increase has occurred in overall on average the BACOG area, that is not a long-term trend we can count on, that there will be increases or sustainability at that level. That the point of the monitoring is to see if in the next 5 years water levels go down a little bit, or over the next 10 years water levels go down or go up. I mean, we don't really know, and the climate is a factor in that, because those short-term storm events and faster runoff and so on may very well affect how much recharge we can capture in the recharge areas. So I think it is extremely positive. We've had an increase, but the caution to take away is it's only 5 years. In groundwater studies, that's not a very long period of time.
I think if we go back, the historical trend is downward still. That, in other words, these water levels were quite a bit higher than they are now 20, 30, 40 years ago.
Yeah, that's correct. I don't know if we have any long-term monitoring that goes back decades within BACOG itself, but we do have monitoring wells outside of BACOG in the sand and gravel system, and the long-term trend is downward, yes. So Janet, that's a great point in terms of, you know, this 5-year trend is a relatively short time. You know, it's really going to be dependent on a combination of water use, changing weather, and you know, we very well could have a significant drought next year, and whatever the 5.8 or 5.6 foot increase overall, that can just go away very, very quickly. So I fully agree that long-term monitoring really is going to be a great planning tool for you guys, and having trends that are more than 5 years, so going into the 10, the 15, 20-year mark, that's really going to give you a great insight into how the aquifer is doing. I
would also point out that I hope another takeaway by the audience is that the BACOG board approved a program, I want to say about a year ago, where we are shifting our natural water quality testing in the aquifer, coming out of the aquifer, shifting it from having random location tests done by our residents to identifying what we're calling semi-public locations, cemeteries, schools, churches with their own wells, to identifying those locations and recruiting those property owners to participate in a new network of wells that are in the set locations where we can do water quality tests year after year after year. Though we wouldn't do them annually, we'd start out with everyone doing a test at the same period of time, and then every 2 years, every 3 years, every 5 years. But that is the idea, to follow on your recommendations and in this report, but it's a program that we started over a year ago looking at, to be able to characterize our water quality here and look for trends in that. So I think we're on target at BACOG for what our groundwater monitoring programs are. And I also want to say thank you to Dan and Walt Kelly from the State Water Survey as well for being a great partner with BACOG as we've developed these groundwater activities and programs. And I appreciate your support in what we're doing. So thank you. Are there more questions from anybody on the phone? Okay, so if not, then I guess we will conclude. And when you get when you make that revision to the report, I'll send it out to everyone, and we will have the recording that we'll be sending out within a few days, I hope. And oh, there's Walt Kelly.
Thank you.
So thank you very much, and we're concluded.
All right.
Thank you.
Bye, everyone. We're figure out how to log off of this. I'm sure it'll happen whether I can or not.